Imagine you're deep in the creative flow, crafting an incredible video. Maybe it's a short film, maybe a game cinematic, or that perfect edit. The visuals look amazing, the story's hitting all the right notes, every frame feels just right, but then you hit that wall, right? The sound. Getting professional grade, perfectly synchronized audio. Well, it can be incredibly time-consuming, complex, and let's be honest, often pretty expensive. What if you could just describe the sounds you need, and an AI could, like, generate those perfect effects for you, on demand, and in stunning high fidelity? Well, get ready, because today we're doing a deep dive into exactly that. We're exploring HunyuanVideo-Foley, an exciting new AI tool from Tencent. And it's promising to really revolutionize how video creators handle sound design. Our mission today: uncover how this thing actually works, what makes it stand out, and what it really means for anyone making videos, from indie creators to the big Hollywood studios.
That's right. We've taken a close look at the official documentation, the research papers around this model. It's kind of a shortcut, really, to getting well-informed about its capabilities. And this isn't just some niche tool. We're talking about a potential game changer for pro-level AI sound effect generation. The applications are just so diverse. Think short videos, film production, advertising, even like complex game development soundscapes. The potential impact is huge.
Okay, let's unpack this then. Get right to the core. So it's an end-to-end video sound effect generation model. Sounds powerful. But what are the real standout features here? What makes HunyuanVideo-Foley different from other sound AI tools we might have seen popping up?
Well, what's truly fascinating, and maybe the biggest innovation, is its ability for multi-scenario audio-visual synchronization. Now, this isn't just about, making sure a sound plays when something happens. It means generating high-quality audio that is not only synced up time-wise, but is also semantically aligned with what's happening in complex scenes. It's about enhancing realism, creating a truly immersive experience for film, TV, games.
Semantically aligned.
Yeah.
Right, so it understands the meaning of the visuals.
Exactly. Think about it. It's transforming sound from just being like background noise into a real narrative element. So if a character is struggling with a heavy, rusty door, the AI doesn't just give you a generic creak. It might generate a strained metallic groan that actually emphasizes the character's effort. It's adding to the story through sound.
That sounds incredibly advanced. But,
Yeah.
okay, what about when you have both visuals and a specific idea described in text? How does it handle that mix? Does one override the other?
That's a great point, and it brings us to the second key highlight: multimodal semantic balance. The AI is designed to intelligently balance information from both the visuals and any text description you provide. It looks at both, orchestrates the sound elements based on that combined input, and actively avoids what the researchers call one-sided generation.
Okay, so it doesn't just ignore your text prompt if the visuals are strong or vice versa.
Precisely. It ensures the final audio considers all the inputs. This means it can meet really personalized, specific dubbing requirements. So if you need that rusty door to have a whooshing sound morphing into a distant chime, as you described, and you type that in, it will try to blend that specific direction with the visual context of the struggling character. It's aiming to enhance creative control, not take it away.
Got it. And for anyone who really cares about audio quality, producers, sound designers, audiophiles listening, this next point sounds huge. 48 kilohertz hi-fi output.
Yeah.
What does that actually mean for the listener experience compared to, say, standard audio?
It means professional-grade audio quality, real clarity, real richness. You see, the model uses a self-developed 48 kilohertz audio VAE that's a variational autoencoder built just for this, and it's designed to perfectly reconstruct sound effects, music, even vocals at that high fidelity. So it's not just generating a sound, it's generating high-fidelity sound.
Which is crucial for professional work, right?
Yeah, absolutely. For creators, this means the generated audio can potentially blend seamlessly with studio-recorded tracks. Or, in some cases, maybe even replace the need for certain Foley recordings altogether. It reduces post-production headaches and helps maintain that premium feel.
Okay, so it claims to be smart, high quality, semantically aware.
Right.
But how does it actually stack up against other solutions out there? The source mentions SOTA performance, state-of-the-art. What's the proof?
Right, SOTA. It's a big claim, but the data seems to back it up. The documentation says it comprehensively leads the field across multiple evaluation benchmarks. They specifically mention results from MovieGen Audio Bench and Kling Audio Evil results. And across all the metrics, they measured audio fidelity, that visual semantic alignment we talked about, temporal alignment.
Temporal alignment, meaning how well the sound syncs with the exact moment of action.
Exactly. Like, does the footstep sound land precisely when the foot hits the ground?
Yeah.
And also distribution matching, making sure the sounds feel natural and varied, not repetitive. On all these fronts, HunyuanVideo-Foley apparently achieved the best scores.
Can you give us an example, like a specific number?
Sure. In the MovieGen Audio Bench, it's MOSQ score, that's mean opinion score for quality. Basically, how good human listeners thought it sounded was 4.14 plus or minus 0.68. That's notably higher than competitors listed in the research. And its desync score, which measures how often the sound feels out of sync, was impressively low at more than 7.4. Less is better there.
So very little noticeable lag or mismatch?
Pretty much. The source is quite confident, stating it genuinely surpasses all open source solutions.
That is impressive. So how does it actually manage all this? Can we peek under the hood a bit at the technical architecture without getting totally lost in code?
We can try. If we think about the big picture in AI research, this task, text video to audio, or TV2A, is known to be a really complex multimodal challenge. HunyuanVideo-Foley uses a sophisticated hybrid architecture. Think of it like having different specialist teams working together. It uses multimodal transformer blocks. These look at the video and audio streams together simultaneously, figuring out how they relate. Then it has unimodal transformer blocks that focus just on refining the audio stream itself, polishing the quality.
Okay, so one part figures out the relationship, the other perfects the sound.
Sort of, yeah. And the key for that perfect sync-up, that temporal alignment, is something called a synchformer. It's based on frame-level synchronization with something called gated modulation. Basically, it's a very precise mechanism to ensure every sound event lines up perfectly with the right video frame.
A synchformer. Sounds like a conductor keeping everything in time.
That's a good analogy. Yeah, it ensures everything lands exactly when it should.
This all sounds incredible, but for our listener, the learner, who's maybe thinking, okay, I want to try this. How accessible is it? Is this locked away in a Tencent lab, or can developers and creators actually get their hands on it?
Good news there. The documentation provides a pretty clear, quick start guide. It seems accessible, at least for those comfortable with some technical setup. The system requirements are laid out. You'll need CDA, specifically version 12.4 or 11.8 for the GPU power, Python 3.8 or newer, and Linux is listed as the main supported OS.
Standard stuff for running AI models, mostly.
Pretty much. The process involves cloning the code repository from wherever it's hosted, setting up your Python environment they recommend using Conda, which is common for managing these things, and then downloading the pre-trained models. Those models are apparently available on Hugging Face, which is a popular platform for sharing AI models.
Okay, so you get it set up. Then what? How do you actually use it to make sound? Is it all command line or?
There are a few ways catering to different workflows. For just doing one video, there's single video generation. You basically point it to your video file and give it a text prompt, your audio description, like wind howling, rain hitting window.
Simple enough. What about bigger projects?
For that, they have batch processing. You can use a CSV file, like a spreadsheet, listing multiple video paths and their text descriptions. It'll just work through the list. But here's the really interesting part for broader accessibility.
I sense a user-friendly option coming.
Exactly. It includes an interactive web interface built using Gradio. You run a command, it launches a web server, you open your browser, and boom, you get a graphical interface. You can upload your video, type your description, hit generate, all through a simple web page. No more command line needed for the actual generation part.
Okay, that's the game changer for accessibility. That makes it usable for creators who aren't necessarily coders, people like me who prefer buttons. That lowers the barrier significantly.
It really does. It opens it up to a much wider range of potential users.
So wrapping up our deep dive today, it feels clear that HunyuanVideo-Foley isn't just another incremental update. It seems like a real powerhouse for creators. It offers impressive quality, that intelligent multimodal understanding, professional output, and the performance benchmarks suggest it really delivers. It feels like it's making complex sound design much more attainable.
It certainly seems that way. And this raises some big questions, doesn't it? How will tools like this reshape the whole creative landscape? When you make high-fidelity, perfectly synced sound effects this accessible, you're democratizing a really sophisticated part of production, where we see an explosion of even more creative, immersive content from smaller creators because the audio barrier is lower.
That's the exciting possibility.
It is, but it also makes you think, will it challenge our ideas about authenticity in media? What happens when more and more of the soundscape is generated, not recorded from the real world? What new kinds of stories or, purely sonic experiences become possible now? It definitely invites us to think about the future of creative production and how we'll experience digital media through sound. Lots to consider.
விஷயங்களை